So the first rule I want to look at is hypothetical syllogism. So we'll state the rule. And I think whenever you state a rule, sometimes the rule isn't very clear until you do some examples. So here's hypothetical syllogism. It says that if you have two conditionals, so if P then Q, and then Q then R, then you can reason to a third conditional, P then R. Now, these conditionals can't be any conditionals. They have to be a conditional where the antecedent of one conditional is the consequent of another conditional. So if we take a look at the statement of hypothetical syllogism, we see this if-then statement, and you'll notice that the consequent of this conditional is the antecedent of this other conditional. So you have these parts of the conditionals that match. And so given that you have this match or you have the same formula, you can reason to another conditional, which is if this part, then this part. So you'll see that you reason from this phi to this chi right here. Okay, so let's look at this a little bit more in detail. Oh, I can't clear all the drawings. All right, so this is just a kind of restatement again, so you could see it differently, but just there's colors this time. Again, we have these conditionals, if phi, then psi. And so you have a conditional. Then you have this match here where the consequence of the conditional at line 1 is the antecedent. The antecedent is just the part to the left of the right arrow at line 2. And so given you have this match, you can reason from the antecedent in the conditional line 1 to the consequent of the conditional in line 2. Okay, so this is not uncommon type of reasoning. People reason with hypothetical syllogism all the time. And you see this a lot when people reason with these chains of if-then statements. So I might say, well, if I go to the store, I don't actually smoke, but this is just an example. If I go to the store, I'll buy some cigarettes. And if I buy some cigarettes, I'm going to end up smoking. And so the conclusion then of taking premise 1 and premise 2 together would be what? Well, if I go to the store, I'll end up smoking. And so you see again that there is this, I'll buy some cigarettes, which is the consequent of the first conditional, and the antecedent of the other conditional. And so we can link these two parts of the conditional together. We can reason from, if I go to the store, I'm going to end up smoking. And you see this also when people have longer chains of reasoning. So there's a famous fallacy called the slippery slope fallacy, where you say, well, if I do this small, innocuous, unimportant, seemingly trivial action, then a certain result will happen. And if that result happens, then another result will happen. And if that result happens, then disaster will strike. And then you'll reason backwards and say, well, I don't want disaster to strike, so I shouldn't do this very small action that sets off this chain of reasoning. Okay. Again, it's also helpful. You can look at things in terms of the formulas. You can look at things in terms of English, but some people appreciate more, visual examples. And this isn't part of the logic itself, but it's just a useful way of remembering the rule. So here we aren't even using sentences, and we aren't using symbols in the language of propositional logic. We're using pictures, and you could, put your own pictures in there if you want, but these were the easiest for me to draw in Photoshop. So here we have if smiley face, then person, if person, then frowny face. And if you're going to use hypothetical syllogism here, you could probably guess what the conclusion will be. Well, if smiley face leads to person and person leads to frowny face, then smiley face is going to lead to frowny face. One thing to note about hypothetical syllogism is it requires two conditionals, and the conditionals have to be of a certain sort. So when you go to cite hypothetical syllogism, you say, all right, I'm going to write a new line in the proof. I'm going to state how I got this new smiley face, therefore, or then frowny face. You want to cite both of the lines that you used. So you'd cite line 1, line 2, and then you'd write hypothetical syllogism. But since that's a lot to write, you can simply write HS to abbreviate it. Okay. The next thing to think about is, when should you use hypothetical syllogism? Well, the point, because I think this is one of the harder parts about propositional logic proofs. You're asked to do a proof, and then you look at it and you say, oh my goodness, look at all of these rules. Which one do I use? There's so many. And so you might start using random rules and say, oh, I'm completely lost. I don't know what to do. So for any rule that you develop, you not only want to know when or how to use the rule, but you also want to know when to use the rule. This one is pretty easy as to when you would use the rule. You would only ever use it, or only ever think about using it, if you had what? 2 conditionals. So if you only had 1 conditional in your proof, you wouldn't say, oh, maybe I should use hypothetical syllogism. Here is, you just look to see, do I have 2 conditionals? And if I do have 2 conditionals, then I'll think about using hypothetical syllogism. I'll see if I have the requisite conditions to use it. So let's look at some examples that would be found in a proof itself. This would be the more concrete example that you might find in an exam. Someone asks you to do a proof on an exam, and so you want to know, like, okay, how would I use it in an actual natural deduction proof? Okay, so we have if P then Q, Q then Z, and then P then Z. So this isn't the most difficult proof, but when we look at this, we'd say, well, what would I write for line 3? What would be the step that I use? What would be the move in the proof that I would use? So I'll give you 10 seconds to think about what you would write for line 3. Okay, so you would write if P then Z, and you'd write that, you justify it by hypothetical syllogism, and then you use line 1 and 2. The reason you would do this is because you see you have the 2 conditionals needed to use hypothetical syllogism. And then you also have that nice little match that you want. You have this Q right here, and then you have this Q at line 2. And so you can link those 2 formulas together to reason to if P then Z. Okay. Here is a more complicated one. This one is not the easiest one to look at. You might say to yourself, well, I'm going to use hypothetical syllogism, but like, what exactly would I write at line 3? So take 10 or 15 seconds to think about what you would write at line 3. Okay, so what you would write at line 3 is if P and S, then not Z. So why would you write that? Well, one is, if you see that line 1, it's not Q. And then at line 2, you also have the exact same formula as the antecedent of that conditional. You have not Q. So you have this formula that you could think about as linking those 2 conditionals together. And so you're going to link this first, the antecedent of line 1, with the consequent of line 2. And that would give you P and S, then not Z. So you're creating a new conditional. And then when you go to cite the whole thing, you'd say the rule that you use, hypothetical syllogism, and then you would cite the lines that you use, which would be lines 1 and line 2. Yeah, so let's say you assumed not Q, then not Z. Oops, it's not Q, excuse me. You could use a hypothetical syllogism in this subproof if you wanted. You would just take this line 3 right here, and it would be found in your subproof, which would now be like your new line 3. So you can definitely use it in the subproof. The issue with, let's say, doing that there's nothing wrong with using that rule, but the issue is that you would have this conditional now in a subproof. And so you'd have to have like a reason for wanting that subproof to begin with. Let's take a look at one more example of this. So I just want to kind of get a sense of whether or not you understand the use of hypothetical syllogism. So I'm going to send out a poll. If you just simply answer yes or no, the question is this a correct use of hypothetical syllogism? So here are the results of the poll. So it's kind of split. Half of the class thinks, yes, this is a legitimate use of hypothetical syllogism, and then a little smaller than less than half of the course thinks that it is not. So is it or isn't it? Well, I would say that it is. So why is it a acceptable use of hypothetical syllogism? Well, notice that we have not M at line 1, which is the antecedent of a conditional, and then not M at line 2, which is the consequent of a conditional. So we have this formula that kind of links these two conditionals or chains those conditionals together. And then when we look at our conclusion here, we have if P then Z. So we're reasoning from if P then Z by way of, or this like chained formula that links those two conditionals together. So this would be an acceptable use of hypothetical syllogism. What might have thrown you off is the fact that I just kind of moved the typical order in which they were presented around. So I usually had this if P then not M, then not M, then Z. But here I just changed lines 1 and 2. And the order really doesn't matter as long as you have this formula that is the antecedent, which is the formula to the left of the right arrow in one conditional, and the consequent in another. Oh, yes. All right, so let's take a look at this one. I'm asking you whether or not you think this is an acceptable use of hypothetical syllogism. Okay, geniuses, look at that, 100%. Everybody's like, no, this is completely wrong. What bozo is reasoning like this? Congratulations, yes, this is definitely not an acceptable use of hypothetical syllogism. There's not that formula that links those two conditionals together, so this is not appropriate. Good work. Yeah, it's not an acceptable use of hypothetical syllogism, and for probably the reasons that you recognized. All right, so it's one thing to be able to look at a proof and say, I can tell whether or not it's appropriate or not. That's like looking at, let's say, an ice skater and saying, oh, I can tell if that's a triple axel. I know the difference between a triple axel and something else. But it's another thing to be able to do it yourself, which is a different task or capacity altogether. So what I'd like you to do is to try to solve the following proof right here, and then we'll walk through it together. So take 2 or 3 minutes and try to solve this proof yourself. Okay, let's take a look at this one. So the first thing for every proof is you want to make sure you set it up correctly. If you don't do this, well, then you're doomed. And also another reason why you would want to do this, even if you can't solve the proof, is because maybe your instructor gives you partial credit, and sometimes they'll give you partial credit for setting up the proof. So even if you don't solve it, you definitely want to set it up correctly. So we do this by simply taking all of the formulas from the left of this single turnstile, or this symbol for syntactic entailment, and list them off one by one. And they're all separated by commas. And then we want a third column for justification. And since they're all premises, we'll write P for each one. Okay. Now the next step is, well, what do we do? And you have a couple options here. And so I'm going to give you one way of solving it. But if you have questions about, like, maybe you solved it in a different way, we can talk about that. And I can tell you, yeah, that's on the right track. It's just a different way of solving it, which is perfectly fine. So one of the things that I looked at was, if I look at lines 1 and 2, I see if P then M, and then I see M then Z. And so I see that M that's in both of those conditionals. And so I say, well, if P then M and M then Z, then it's going to follow that P then Z. And so at line 4, I wrote if P then Z, and I got this by hypothetical syllogism, and then I cited both of the lines that I used. Okay, well, this is not the conclusion, so we need to do something else. And so the next step would be to try to reason to the conclusion, which is if P then W. And so if we look at line 3, we see we have if Z then W. And if we look at line 4, we have if P then Z. So what we have is this Z right here, which is the antecedent of line 3, and Z right here at line 4, which is the consequence of line 4. So when we reason to the conclusion, we can reason to if P then W, and we use lines 3 and 4 to reason to if P then W. So in this proof, we use hypothetical syllogism 2 times, once to get P then Z, and the other time to get P then W. Let's take a look at this next proof right here, where it's a lot longer. And what I'd like you to do is just to take a moment and see if you can solve it. Absolutely. You know, you weren't thrown off by my how many, like, what are the many steps that you use? Look at all these other formulas at line 2 that need to be used. No, you can just reason directly to A and B then Z, just like you said, using lines 1 and line 3. What you recognized was that there was this M at line 3 and then M at line 1. And so you could link A and B to Z, getting you the conclusion straight away. Another thing to note about hypothetical syllogism is you kind of never really need this rule. It's kind of a junk rule. More exact, it's called a derived rule. A derived rule means that you can use a more basic set of rules to do all of the proofs that hypothetical syllogism does. That is, you can actually prove hypothetical syllogism itself with a smaller subset of rules. So the question would be like, why do I want hypothetical syllogism? What's the point? The whole point of having it in your rule system is just because it simplifies proofs. It makes some types of reasoning, some types of proofs a lot shorter. And the cost is you have another rule to remember, but the benefit is that you can shorten some of the proofs. So it's worthwhile to try. This isn't the most difficult of proofs to solve, but it's worthwhile to actually try to solve hypothetical syllogism itself without using hypothetical syllogism. So what I would like you to do here, or at least try to attempt, and it's perfectly fine if you don't get it, is to try to prove hypothetical syllogism without using hypothetical syllogism. So take, 3 minutes to try to prove this particular proof. Okay, let's take a look at this one. So to solve or prove hypothetical syllogism, what we would want to look at is the conclusion that we're trying to derive. And if you look at the conclusion, it is a conditional. And so you might say to yourself, oh, what I want to do is introduce into the proof a conditional. And so if that is your thought process, you might say, I'm going to use the rule that introduces into proofs conditionals, which is conditional introduction. That rule involves assuming the antecedent of the conditional you want to derive. So you're going to create a subproof that starts with the antecedent of the conditional you want to derive, and then trying to derive in the subproof the consequence of the conditional. So this is what you would do. You would assume P, because that's the antecedent of the conditional we want to derive. And then we say to ourselves, okay, now I want to derive R. It's the formula I want to get. So how do I do this? Well, if I look at lines 1 and line 2, since I have P at line 3, I can use this conditional elimination to derive Q. So I assume P is the case, and I see line 1 says, if P then Q, I have P, therefore Q is the case. So I can write Q at line 4 using conditional elimination. Now that I have Q at line 4, I look at line 2 and say, oh, line 2 says, if Q is the case, then R is the case. And so since Q is the case as it's established at line 4, then R is the case. So at line 5 now we have R. Okay, so what was the point of making this assumption? Well, we assumed P, and then our goal was to drive R, which we have done. And now we can use this conditional introduction rule. And conditional introduction says that you create or derive a conditional based upon this subproof where the antecedent of the conditional is the formula that you assumed, which was P, and the consequent of the conditional is the formula that you derived in the subproof, which was R. And so we can use conditional introduction at line 6. Okay, so what does this show? One thing it shows is you don't need to use hypothetical syllogism. You can just do this every single time you are planning on trying to, instead of using hypothetical syllogism. But it also shows that if we ever wanted to use hypothetical syllogism, it would save us 1, 2, 3 steps. And these are 3 steps that we might not want to go through. So we get a benefit of hypothetical syllogism in that we don't have to do this type of proof every single time. We want to reason in a way that's really natural for people. People reason all the time. If P, then Q, Q, then R. So if P, then R. And so again, you don't ever have to really use hypothetical syllogism, but having it in your arsenal will allow you to save steps because you won't have to do all of these steps here.